So our topic today is going to be TPMS operation and testing. So tire pressure monitoring systems have been around since, couple decades now at this point. They're ubiquitous. They're everywhere. They're on more than just automotive products at this point as well. We'll get to that a little bit later. But first, we're going to start off with some history, and then we're going to talk about how it works and all sorts of other good things. So first off, the history. Back in 1986, the first full-fledged production vehicle, I guess you could say. I'm sure there were probably others that had been produced at some point, but not on a large scale. Porsche 959, 1986. Now, this system used two sensors mounted 180 degrees apart in special holes in the valley of the wheel. The sensors looked like a little stack of poker chips, so a little about that round and a little stack of chips. It transmits at a 433 megahertz frequency. That'll come into play a little bit later when we talk about the differences between the different sensors. You would get the codes and data from the scan tool, and it was also used for 928 models from 1990 through 1994. First production U.S. vehicle can be the 1997 Corvette C5. It was Schrader, and it was the first OE TPMS provider there. Vehicle manufacturers had no standard tire pressure monitoring systems, and they really don't have many real standards now. It's different ways to do things and program them and everything. I guess the light itself, the messaging system is pretty uniform across the board, but back then it wasn't. And to activate this sensor, it had this little magnet that you would put over it. So you put a magnet over the top of this, and that would throw a little magnetic switch inside there, pull a little magnetic switch up, and then that would indicate or to the module that it was on. That's why if you've ever seen like I remember back in the TPMS 3, there was a place in the case to put this, and it came with that little magnet and was stored in the case there back in the TPMS 3 days. So, been around for a while. Then in 2000, a large U.S. vehicle manufacturer recalled a bunch of vehicles. I think you may know who that manufacturer was. And due to rollover deaths, it was a total of 14.4 million tires they recalled and 279 accident deaths. And a lot of it had to do with the vehicle. The placard on the vehicle was not correct for what the manufacturer recommended for the tire. The manufacturer, of course, wanted to give a nice smooth ride. So, maybe a little bit lower on the tire than what the manufacturer of the tire wanted. So then it caused a lot of issues. So the law, the Tread Act, intends to increase consumer safety by mandating TPMS in all vehicles under 10,000 pounds. Starting in 2004, it was assigned to the NHTSA, the National Highway Traffic Safety Administration, and it was required to notify the driver when the tire is below 25% by a dashboard warning light within 20 minutes. Seems like an awful long time. So warning light requirements, a solid light is when the tire pressure detected is under or over 25% of the OE door placard value. And because the tires and the placard values might be a little bit different, we have to have a way to go in and change that, which on some vehicles we have that. Flashing for 60 seconds, then a solid light means at least one sensor isn't communicating with the vehicle. Could be a dead battery or damaged sensor. Could be an incorrect relearn or an additional tire pressure monitoring component failures, such as a module, a wheel initiator, an ECU, etc. And you, of course, would have to diagnose that using a scan tool. And kind of how it works, if you're not aware, is there's going to be some sort of a module, usually center-ish in the vehicle. A lot of times it's on like the tunnel, the transmission tunnel on the vehicle, or somewhere in the center console, somewhere kind of in the middle, so it can receive the data from the tire pressure monitors around the outside of the vehicle. Could also be one in the spare. That's definitely a thing that happens. And then dual wheels, like on a pickup truck, could be there as well. Could have multiple sensors on there. So they are transmitting back and forth, and they each have an individual ID for those. So that way the computer in the car knows, okay, the left front one is this one, and the right front one is this one. So when it says the right front pressure decreased, as long as the vehicle knows correctly where they are, it'll tell you the proper tire. So that is why it's very important, especially rotating tires and things of that nature. We need to make sure we reset and relearn those tires to the proper corner of the vehicle and make sure the vehicle knows where it is. So like I said, it's basically it's got a hexadecimal sensor ID number in there programmed into it. Oftentimes it's on the sensor itself. We'll have an RF antenna which transmits the information, and also we have a battery in there. So a lot of people don't necessarily take that into consideration. I think maybe nowadays, since it's been long enough, but it is a non-replaceable lithium-ion battery. Average 7 to 10 year life expectancy. My vehicle's 13 and I still haven't replaced them myself. I don't know if they've been replaced when I got my tires changed. Perhaps they did. I don't recall seeing a line item for that, but maybe they did. Otherwise, it's lasted a pretty darn long time for 13 years. So when the battery dies, it will throw a code and it'll throw a light on the dash. So you'll know. And it'll just say no, probably just say no communication with the sensor. But I'll tell you the battery status, whether it's good or not, whether it's low or not. The different types you're going to find out there, probably way fewer of these are going to be out there. So these are banded. Actually, I've seen some banded sensors on for like upgrades for trailers, things like that. It just comes with a big band, kind of looks like a worm clamp, radiator clamp, like the worm gear of radiator clamp, wrapped around the tire rim. Very uncommon now. Ford was the major player with those. They discontinued them in 2009, 2010. Most manufacturers actually really use this snap-in design nowadays. I'm sure you'll still see some clamp-in ones. Problem with the clamp-in ones, especially if you're up from where I live in the snow belt, they put a bunch of crud on the roads. It gets in there, and then they corrode it. Very, very difficult to change these once they get corroded in there, once they get a little bit of road salt or whatever. Very, very hard to change. I remember at Subaru, the first 2 or 3 years that they had them as factory on the vehicles, they were this style, and we had to cut them off very often in order to change the tires or whatever, or to change the sensors. We'd have to cut them off, just take a grinder and cut right down the middle and snap them off. Simple aluminum, but when they would corrode, man, it'd be terrible. So like I said, a lot of manufacturers have now gone to the snap-in style where it snaps in the rubber just like a normal rubber valve, and then it also has this sensor on the outside of it, so it's able to sense the air pressure and also do the transmitting and so on. Good for winter salt reasons. 07 to 2020, Schrader's been developing these since then, so many different types on there. You can see the different part numbers down there. Two-piece, low cost, easy to install. Theoretically, you don't have to change the rubber part when you're changing the sensor. If the sensor like breaks or something, you could just change just the sensor itself. It's easy enough to change anyways, and I believe most of them probably come with the rubber anyways. Important to know, though, is that on the back side of it, the screw that goes in there is a special torque spec for that, and it's not very much. So you want to use maybe a special small torque screwdriver. And then also the Schrader valve itself, Schrader developed. Schrader valve itself also requires a small, this one says preset at 4 inch-pounds. Right, so you want a very, very small amount of torque. You don't want to snap them off. And that is what we would call a direct pressure measurement. So 94% of the U.S. market uses that, what we call a direct tire pressure measurement. About 6% of the market in the U.S. is indirect, so it actually uses the wheel speed sensor and tells the difference between the wheel speed to know whether or not that tire is low or not. So the tire, obviously, if it's got lower pressure, it's going to spin at a different speed than the other ones that don't have a lower pressure. So that's kind of how they use it. I know somebody I was talking to, they had a Hyundai for a rental a couple months ago that used that style, didn't have tire pressure sensors in there. So the majority of what you're going to run into is going to be that direct. And like I said, very few is that indirect, but there are some newer Accords, Audis, etc. In 2009, VDO introduced a multi-application ready sensor. So that is a universal sensor. So that would be for 6 or 7 different part numbers available for both the 315 megahertz and the 433 megahertz applications. Remember how I said that would kind of come into play a little bit later. And has all the different OE protocols stacked on a single sensor chip in there. So you can actually clone a sensor using maybe a TPMS4, TPMS5, something like that. See how I have the sensor there, and it would actually just using the radio frequency, you can copy off the old one, put on a new one with that. So there's multiple different brands out there now. VDO is just the first one, but there's multiple different brands out there. We cover on our tools over 20 different brands of programmable sensors. I can see a few of them listed there: Alligator, Alpha, Bosch, BWD. And then there's different ways to go through it too. You can go by country of origin, sensor software type, frequency options, etc. So there's multitude of different ways to go through the tool and figure it out. Now, to that point as well, there's no standard service relearns on TPMS either. So GM itself, and this was, I think, a couple of years ago, we counted this, but could be more nowadays. GM had 33 different procedures. BMW had 15 different procedures. Nissan had one procedure using either the OBD2 or not. And then you can kind of see the breakdown there. 27% go through the OBD2 port, 38% are automatic relearns, 35% are stationary relearns where you don't have to drive the vehicle. And you can see even on the same manufacturer, GM's got totally different ways to do it. So let's walk through a couple different example reset procedures. So this one's on one good way to find them, should I say, before we get into that. One good way to find the reset procedure is if you have one of the tools, one of our tools with a quick lookups function. So that's pretty much all of them nowadays. Any of the Wi-Fi enabled tools would have this function, even down to the Ethos Edge. So you'll see the quick lookups on the front menu. And then in there, it gives us options for tire, wheel service, oil specs. And on the Veris and the Zeus TSBs as well, all the others will just have tire and wheel and oil specs. But if we go into tire and wheel, it's going to come up. It's going to give you different procedures. The specific procedure for the vehicle. So in this case, we have an 18 Acadia. That is number 11 out of the many different procedures on GM, as we said. It's going to walk you through how it works. 2018 BMW, there's one of the 8 different procedures on there or more. That's going to tell you how to do it actually using the iDrive, the little onboard computer. On 2018 Ram, it's not actually published. So you would actually go in and do or at least in this case, it wasn't published. You'd actually go in and do a functional reset through the scan tool. Now, of course, this is a security link function on an 18 and newer RAM. So you actually, if you have our TPMS5 tool, you can actually hook it up with AutoAuth and be able to use it through the security gateway as well. But in this case, you go in and you program the left, right, etc. tire IDs there. It says this function to be used to write the left front tire ID in the ECU is the one I picked. And it'll show you whatever the current ID is. And then please make sure you have 8-character sensor ID on the tire sensor label and the tire sensor itself. You go in, you hit edit, punch it in, hit OK. It's going to make sure you confirm the characters, and then it'll go through and say it's successful. It's done. And then on Nissan, remember how I said there's 2 different ways, one with an activation tool and one without the activation tool? So with the activation tool, it's going to go through one way using the scan tool. And then if I don't have a transmitter activation tool set, it's going to have me set my tire pressures to a certain amount. So I go under functional resets, there's with or without. So the J45295 tool is going to be something like this: TPMS4, TPMS5, TPMS3. Just something to activate the actual sensor. And then also without the tool, there's going to be a different way. And actually it says only work with existing sensors. If new sensors are installed, you have to use the tool. So it's going to tell you to adjust the tire pressures accordingly, and then go to the next message, and then drive the vehicle until the test completed screen is displayed. Vehicle must be driven, and then the tire pressure light will go out. If the test fails complete, exit the test and try it again. Following the instructions in greater detail. So we set the tire pressures, and the vehicle is going to go down the road. And when it sees this one's at 36 and this one's at 34, it's going to know which one is where on the vehicle. Other scanner operations you may need or want to do with the tool is going to be, say, for example, on Acadia, tire type or pressure selections. You can go in there and select your tire type, and then select the pressure. So you actually go in and hit edit, and then there's options anywhere from 26 to 95 psi. and anything in between. Pretty much anything in between allows you to go through there and set those tire pressures. So you set it for a lower pressure if you're going, say, maybe off-road or something like that, or a higher pressure if the tire calls for it as well. So for example, if I wanted to set it to 44, I could go in there, goes to 44, hit continue, and it programs. Now, what happens if I have a non-communicating sensor? Oftentimes you can go in the scan tool and read the ID. So if you can't read it off the tire pressure tool, it will tell you what the last ID it saw there was. If you actually go into scan data, you can see it that way as well to retrieve IDs of the dead sensor, and then you can enter it on the tool after the fact. Motorcycles also have tire pressure monitoring now. So Honda, BMW, Indian, Harley, they have obviously tires. So they have tire pressure monitors in those tires. Here's an example on a Honda GL 1800, and you can see it's front and rear. Easy enough. You can go and trigger the sensors, pull that information. Dually trucks as well. 2019 and 2020 and newer OE trailer TPMS is in there as well. So manufacturers started adding trailer TPMS in there. So you can see trailer setup down there on the cluster. So you can go in there and pull it. And then on like a Super Duty, you can see we got 1, 2, 3, 4, 5, 6 tires. So inner left rear and inner right rear is what those mean. Do that. Also on trailers, a manual setting. Also now cover Bluetooth. So Tesla decided, being different as they are, to use Bluetooth low energy tire pressure sensors instead of our standard radio frequency ones that we've been used to before. So it's 2.4 gigahertz on there. I don't know why it says megahertz up there, but it is gigahertz frequency. And you can just go in and we can program those as well using the TPMS 5. So the May 2023 update, so that's been a little over a year. With that update, you're able to program and read the frequency, etc. So 3058 millivolts and 2.4 gigahertz frequency there. So we can read that. So yeah, another update. If you have a TPMS 5 and you want to work on those vehicles and you don't have the update, then you can just simply add the update and then you'll be able to do that. So pretty cool. All right, let's go live on the tool. Look at a few things that we can see. So first one I'm going to do is a GM. So I got a 2016 Equinox loaded in here. Going to the scanner. And oftentimes, I will not say every time, but oftentimes, it is going to be considered a common selection on a vehicle. So it's usually going to be up on top here. Down below, you could also go down to would be tire pressure monitoring down below. But in this case, it's up here. And we see we got codes, data. What do we got for data? We got sensor data and system data. So we go into sensor data. We can see tire pressure signal qualities and signals and percentages and so on. And if I go into the other data, it's going to be your different tire types, pressure IDs, sensor IDs, etc. Last location learned, pressure status, pressure in the tire, sensor mode, etc. So the 4 tires there. For functional tests, we can go in and we can go under output controls, and that's where we'd actually put it into our tire pressure learn mode. So use a Snap-on TPMS sensor activation tool, 1, 2, 3, or 4, or 5. You can go in and activate the sensors that way, and then just hit learn, and then you would go around the vehicle and it would learn. We also have tire type and pressure selection. So this is where we could change the tire. So say we wanted to do like change the deload range. Tire on there, and then go to edit, and then we can go in and change it to whatever we want, say 45. Continue, and it programs it in. Very simple, easy enough to do. Right. Back. Another way to do it is if you have the service resets and relearns on your scan tool, which some of our scan tools have. You can go in there, and it will be once again. We have for maintenance, it'd be under maintenance, or it could be under, let's see, tire pressure monitoring system as well. So if I want to replace the tire pressure sensor, can go in there. It's going to give us some data, some TSB information, and then it'll pull up any of those functional tests that we might need. So tire type of pressure selection, TPM alert mode, tire pressure sensor signal reset. So these are all the functional tests for that, related to that we might not necessarily, we won't have to go into different places in the module to find it. Brings it all right here for us. Okay. And then remember also how I said we can go into quick lookups. So if I go into quick lookups, see tire and wheel. And in this case, Equinox, right? Okay, and then there we go. It's going to bring us right down to our tire pressure monitor number 33. That's how we would do it. Functional reset would bring us into scanner. Remove and repair would show us how to remove and repair it. So for example, this there's tire pressure monitor right there. Tell us how to do it. Also has tire fitment information as well. So front, rear, both, inflation pressures, wheel nut torques, wheelbase, tire size, rim size, bolt size, number, and how many millimeters apart they are, the bolt pattern, weight, optional tires, etc. So all that information right at your fingertips, right at the tire and wheel service on there, and then we could print it out if we wanted to. I'm not going to, but we could. All right, so that's our Chevy. Let's go in and look at a Grand Caravan, a little older vehicle. It's going to be a little bit different way of doing things. But once again, it's going to have a tire pressure monitor there. Now, on a Chrysler vehicle, could be in the tire pressure monitor module by itself or in the wireless control module. So the tire pressure module, codes data, miscellaneous functions, some resets in there, system tests. Going to be, this is where I have to actually type in the sensor. So you can go in, 7-character ID. There's current ID. Go in there, hit edit. 2, 3, 4, 5, 6, 7. Okay. Hit OK. Programs it in. Wants to verify it for sure. Hit continue. And then there we go. Of course, the simulator is not going to show that. Also, a rolls test verifies the TPM sensors are transmitting and being received by the TPM module and should be run when new tire sensors are programmed. Says a driving. Must be above 20 miles an hour for at least 30 seconds after the procedure starts in order to force the sensor transmit. Begin driving. And it would go and you would drive. And it would double check and make sure that it's rolling and working. Okay, and then the wireless control module in this case, there's going to be some ECU information and like an antenna loop test to test the wireless where it can receive from there. Okay, next one we have is the Mercedes. So on the Mercedes, once again, tire pressure monitor right there. Simulator, so sometimes you got to pick one. Okay, codes, data, functional tests, special functions, right IDs of the tire pressure sensors. So do I know what the sensor IDs are? Otherwise, it's going to be printed on the respective wheel sensors. It's going to remind you that they're printed on the wheel speed sensors, and then you can just select the wheel, edit. Just go in there. Program it. Program it. Coding completed successfully. If the correct pressures are shown after a short drive, then the teach-in process was successful. If a warning appears on the instrument cluster, then repeat the process. And then also we have actuator tests. So that's going to be test that you're transmitting. Please ensure all the tire pressures have been constant for at least 2 minutes. You require to release pressure from the tire to wake up the sensor. There we go. Okay, and then last one we're going to look at is the F350 dually. Remember how I said we do dualies? And you'll have 6 tires, or 7 if you do a spare. Series. Okay. Service resets. Should have one for tires down here. Yeah, tire pressure sensor. Functional resets. Training mode with scanner, training mode without scanner. So we'll do with scanner. Cycle the key. We'll enable location training mode. Okay, and then it's going to show you your pressures, status. Since it's a simulator, I don't have all 6 tires, but we would see that because this is fronts and then rear outers, rear inners. We'd have more data on a real life vehicle. Once you put it in this mode, the horn will sound. Use the tire pressure monitor system sensor activation tool to activate left front sensor. Be for right front, right rear, left rear, and that is important. That's every single manufacturer is the same way. You start with the driver's side front, then passenger front, passenger rear, driver rear. So you're going clockwise if you're looking on top. If you're looking down from the top of the vehicle. Do not exit until all sensors are trained. Selecting exit will end it. Perform a self-test to clear the codes. All right. So that is tire pressure monitors. Hopefully you learned a few tips and tricks on that, and hopefully you can use it in your day-to-day because, well, we should be using it day-to-day, especially if you're doing maintenance, changing tires, rotating tires even. So that is TPMS. Let's talk about what we're going to talk about next week. So next week we are going back on our OEM specific training, and we are talking Tesla next week. Talk about what makes them unique, and there's quite a few different things that make them unique. Different things we can do with the scan tool on them, different things data we can find on ShopKey, etc. So join me as always, 6 and 9 Eastern. You can join me on Zoom at snapon.com/OT. Otherwise, the 6 p.m. class goes live to our YouTube channel like we're doing right now. Also the 9 p.m. class goes to my Facebook page. So it's facebook.com/snaponjason. If you want to see any of the past topics in this series, we're actually up to 101. I didn't change that slide, but we're up to 101 classes now. Anywhere from ADOS to our OEM specific training, EVAP, everything in between. So check it out. They're all available on our YouTube channel, youtube.com/snapon-diagnostics. Make sure you like and subscribe. Also, if you scan that QR code, it'll automatically bring you there and subscribe you automatically. Make sure you check that out. Also, do we have your email address? If we do not have your email address, you're missing out on lots of things like technical focus articles, SureTrack blogs, quick tips, new product release announcements, my training schedule. All of that stuff gets posted on the emails. It's maybe 1 or 2 a week at most that we send out. We're not going to spam you. But if you see, here's one article that we sent out on timing chains to see how you can figure out whether you have a stretched timing chain or not. So that's just one of the many examples. So if we don't have your emails, if you're not getting one of these emails, scan that QR code right there, and that'll bring you into where you can enter in your information. All right, time for questions. But before I do, I just want to make sure I mention my buddy Keith. So Keith also does live diagnostic training every Wednesday and Thursday. So it's at 7:30 Eastern, 6:30 Central, 4:30 Pacific. It is Zoom only. It is kind of designed to have the tool in front of you. So you're watching along on the tool as he's functioning along at his tool there. snapon.com/OT to sign up there. And that will be Zoom only with that. So he's been with us over 30 years. Very deep well of Snap-on tool knowledge. So definitely worth checking out. All right, let's get to questions. We've got a couple on Zoom. Let's see. I got one on Zoom anyway. Jay says, no questions. Thank you for the class. All right. Thank you very much for chiming in. Let's go to YouTube quick. Miguel has said, she said this right before the class started, but I have a Snap-on Solus Plus. What are the key fobs I can do? And I referred him to our Snap-on coverage website. So it's us.snaponcoverage.com for the US. I think we also have one for the UK and one for Australia. Jaylee Lobo says hello. Hussein says hello. Thank you. Edward C says, I've definitely replaced the battery in TPMS, and it is a pain in the butt. I would imagine it probably is. Nick says hello from England. And also says hi to Keith for Ray in the Bay, too. That's our new series we put out. We've got 4 or 5 episodes now. The Winton says hello. And that's about it. Nick says, very useful. Can't wait for next week's training. So with that, got another one on soon. Oh, Edmund from Cal Fire. Hello, welcome. Thanks for joining us. All right. So with that, if I can get this thing to move. There we go. Thank you very much. Thank you for spending a little bit of time with me. Hopefully you have gotten a little bit more education on the inner workings of the TPMS system. Oh, got another one here. Working on Dodge. Okay. Maybe you could shoot me an email or shoot me a message on Facebook. That'd be fine too. Because usually it's a little more involved if you have questions on specific vehicles sometimes. So that might be your best bet. So look me up on Facebook. I have Messenger on my phone. I can usually answer pretty quick. So yeah, check that out. All right. So with that, thank you very much. Thanks for spending a little bit of time with me. Hopefully you got a little bit more out of your TPMS. Hopefully you'll join me next week for Tesla. With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care. Oh, so he's saying, have a question about trying to get through the gateway on Dodge. So best bet to do is watch one of my many secure vehicle gateway training vehicles, our videos. So those are up on our YouTube channel. You can go watch those. And I talked about it multiple times. So you just watch through the videos. I walk through how to do it and where to put your particulars and all that stuff. So that's the best way to do it. You do need an on-off account. You do need to have your tool synced up with your Snap-on Cloud account, but definitely the best way to go about it. Just watch those videos. I walk you right through it. Great. Thank you very much. All right. Have a good night, everyone. Take care.